So let's dive into our first topic, understanding the tilt of Earth's axis and its role in creating seasonal changes. This Earth's axis is an imaginary line that runs through the center of the planet, from the North Pole to the South Pole. The Earth is tilted at an angle of about 23.5 degrees in relation to its orbit around the Sun. This tilt is essential for the existence of seasons on our planet. Now, you might wonder why the tilt of the Earth's axis affects the seasons. Well, as the Earth orbits the Sun, the tilt causes different parts of the Earth to receive varying amounts of sunlight throughout the year. When the northern hemisphere is tilted towards the Sun, it receives more direct sunlight, leading to the warm temperatures and long days of summer. Conversely, when the northern hemisphere is tilted away from the Sun, it receives less direct sunlight, resulting in the colder temperatures and shorter days of winter. This varying amount of sunlight is due to the angle at which the sun's rays strike the Earth. When the sun's rays hit the Earth directly, they are more concentrated and therefore provide more warmth. On the other hand, when the sun's rays hit the Earth at a more oblique angle, they are less concentrated and provide less warmth. This is why the areas near the equator are generally warmer, as they receive more direct sunlight throughout the year, while the polar regions are colder, as they receive more indirect sunlight. So, in a nutshell, the tilt of Earth's axis plays a crucial role in creating seasonal changes by causing different parts of the planet to receive varying amounts of sunlight throughout the year. Moving on to our second topic, let's discuss how Earth's orbit around the Sun and the changing angle of sunlight affect temperature variations and the duration of daylight during different seasons. As we mentioned earlier, the Earth is tilted at an angle of about 23.5 degrees, and this tilt remains constant as the Earth orbits the Sun. Throughout the year, the Earth's position in its orbit changes, which means the angle at which sunlight reaches the planet's surface also changes. This variation in sunlight angle, combined with the Earth's tilt, causes the temperature differences and changes in daylight duration that we experience during different seasons. For example, during summer in the northern hemisphere, the North Pole is tilted towards the Sun, causing the Sun's rays to hit the Earth at a more direct angle. This results in longer daylight hours and warmer temperatures. In contrast, during winter, the North Pole is tilted away from the Sun, and the Sun's rays strike the Earth at a more oblique angle, leading to shorter daylight hours and colder temperatures. In addition to the tilt of Earth's axis, the shape of Earth's orbit also plays a role in seasonal temperature variations. Earth's orbit is slightly elliptical, which means that the distance between the Earth and the Sun changes throughout the year. When the Earth is closest to the Sun, we experience what's known as perihelion, and when it's farthest away, we have aphelion. However, this variation in distance has a relatively minor impact on seasonal temperature changes compared to the effect of the axial tilt. So, to sum up, Earth's orbit around the Sun and the changing angle of sunlight, together with the tilt of Earth's axis, are responsible for the temperature variations and the duration of daylight that we experience during different seasons. Now let's explore the concept of solstices and equinoxes, which mark the beginning of astronomical seasons, and occur due to Earth's axial tilt and orbit. These events are significant because they help us understand the changing of seasons and the varying amounts of daylight we experience throughout the year. Solstices occur twice a year, around June 21st and December 21st. The June solstice, also known as the summer solstice in the northern hemisphere, is the day when the North Pole is tilted most directly towards the Sun. This results in the longest day of the year for the northern hemisphere and the shortest day for the southern hemisphere. On the other hand, the December solstice, or winter solstice, is when the North Pole is tilted furthest away from the Sun. This leads to the shortest day of the year in the northern hemisphere and the longest day in the southern hemisphere. Equinoxes, on the other hand, occur twice a year as well, around March 21st and September 23rd. During an equinox, the tilt of the Earth's axis is perpendicular to the Sun's rays, which means that the Sun is directly above the Earth's equator. As a result, both hemispheres receive an equal amount of daylight, and day and night are approximately the same length all over the planet. The March equinox, also known as the spring or vernal equinox, marks the beginning of spring in the northern hemisphere and autumn in the southern hemisphere. The September equinox or autumnal equinox signals the start of autumn in the northern hemisphere and spring in the southern hemisphere. In summary, solstices and equinoxes are essential astronomical events that result from Earth's axial tilt and orbit around the Sun. They mark the beginning of different seasons and help us understand the variations in daylight and temperature throughout the year. Let's now discuss how the hemispheres experience opposite seasons due to their position relative to the Sun and the tilt of Earth's axis. As we've already covered, the Earth axis is tilted at an angle of about 23.5 degrees, which plays a crucial role in the creation of seasons. This tilt causes each hemisphere to be exposed to different amounts of sunlight throughout the year, affecting the temperature and overall climate. When the northern hemisphere is tilted towards the Sun, it experiences summer, while the southern hemisphere, tilted away from the Sun, experiences winter. This is because the northern hemisphere receives more direct sunlight, leading to warmer temperatures and longer days. Conversely, the southern hemisphere receives less direct sunlight, resulting in colder temperatures and shorter days. Approximately 6 months later, the situation reverses as the Earth continues its orbit around the Sun. The southern hemisphere is now tilted towards the Sun, experiencing summer, while the northern hemisphere, tilted away from the Sun, experiences winter. During the equinoxes, both hemispheres receive approximately equal amounts of sunlight, as the tilt of Earth's axis is perpendicular to the Sun's rays. This results in similar day and night lengths across the globe and marks the beginning of spring and autumn in the respective hemispheres. In summary, the hemispheres experience opposite seasons due to their position relative to the Sun and the tilt of Earth's axis. As one hemisphere tilts towards the Sun, it receives more direct sunlight and experiences warmer temperatures, while the other hemisphere, tilted away from the Sun, receives less direct sunlight and experiences colder temperatures. This constant shift in the Earth's position relative to the Sun results in the changing of seasons that we experience throughout the year. Lastly, let's investigate the impact of seasonal changes on ecosystems, weather patterns, and human activities, including agriculture and cultural traditions. Seasonal changes have significant effects on our planet and the way we live our lives. Starting with ecosystems, the change in seasons directly impact plants and animals. For example, plants have adapted to grow and complete their life cycles during specific seasons, with some blooming in spring and others in summer or autumn. Similarly, many animals have evolved to adapt their behavior and physiology to seasonal changes. This includes hibernation during winter for some species, migration to warmer climates for others, and changes in mating and reproductive behavior to align with the most favorable conditions. Weather patterns are also greatly influenced by seasonal changes. The varying amounts of sunlight and the angle at which it reaches the Earth's surface cause temperature fluctuations, which in turn affect atmospheric pressure, wind patterns, and precipitation. These factors give rise to various weather phenomena, such as tropical storms, blizzards, and droughts, which are often associated with specific seasons. Human activities, particularly agriculture, are heavily influenced by seasonal changes. Farmers rely on the predictable patterns of temperature, rainfall, and daylight hours to plan their planting and harvesting schedules. In many parts of the world, traditional agricultural practices have been developed in response to local seasonal patterns, ensuring sufficient food production throughout the year. Seasonal changes also play a significant role in cultural traditions and celebrations. Many holidays and festivals around the world are linked to seasonal events, such as the arrival of spring, the harvest season, or the winter solstice. These celebrations often involve specific rituals, foods, and activities that have been passed down through generations. In conclusion, seasonal changes have a profound impact on ecosystems, weather patterns, and human activities. They shape the way plants and animals survive and reproduce, influence the weather we experience, and play a crucial role in agriculture and cultural traditions. Understanding the reasons behind Earth's seasonal changes helps us appreciate the complex interplay between our planet, its climate, and the life that thrives on it.